Namaskar. Now, actually, in school itself, we have studied the image formation because of the convex mirror, concave mirror, convex lens, and the concave lens. I remember those days, my teacher Sati sir has teach me how there is a formation of image. And I remember that he told me that two rays are important. One, the ray which is traveling to parallel to the principal axis. Now in case of mirror, it makes equal angle with the normal. Correct? Now this is the normal to the mirror at that point and it makes equal angle during reflection. In case of the convex mirror, it gets reflected away from the axis, and in case of the concave mirror, it deviates towards the axis. The another ray which we will have to consider is the ray which is traveling towards the pole of the mirror, and in case of the mirror, it gets reflected from the mirror making the same angle with the principal axis. Now here also it makes the same angle with the principal axis, and it is just the law of reflection. Angle of incidence is equal to angle of reflection. In case of a lens, this is the pole of a lens, and the ray which is traveling parallel to the principal axis, after passing through the convex lens, it passes through the focus towards right. Therefore, this is the focal point and it passes through the focus. Whereas the ray which is traveling towards the pole travels undeviated. Therefore, these two rays are important. One, the ray which is traveling parallel to the principal axis, which passes through the focus, and the ray which is traveling towards the pole travels undeviated. In case of concave mirror lens, the ray which is passing parallel to the or traveling parallel to the principal axis, after passing through the lens, travels in such a way that it appears to be emerging from the focus. Therefore, here it appears to be emerging from this focus. This is the focus of concave lens and this is the focus of convex lens. Whereas the ray which is traveling towards the pole travels undeviated. Right? Now I remember the school days in 9th or 10th, he has teach us, and with that foundation, till today I remember how we can think about or how we can prepare the diagram or draw that schematic diagram of image formation due to the mirror. It may be convex, concave, or image formation due to the lens. It may be convex or concave. Now today we shall discuss the image formation due to convex lens. Whenever the object is at different point, we will have to consider the Cartesian sign convention. Here it is the position of lens. Always I will not show you the lens something like this. Just I will draw a line, vertical line, and I will represent this is the lens, thin lens typically. Then one more line is important or one more point is important, that is F towards left and F towards right, and another is 2F towards left and 2F towards right. According to the Cartesian sign convention, object is kept to the left of the mirror and ray should travel, incident ray should travel towards the lens parallel to the principal axis or incline, whatever it may be. But typically we will have to keep the object to the left hand side. This side or these distances are assumed to be negative, these distances are assumed to be positive. The direction above the principal axis represents the positive direction, whereas the direction below the principal axis represents negative direction, and there is a formula 1 upon f is equal to 1 upon v minus 1 upon u. This is the lens equation where f is the focal length, v is the image distance and u is the object distance. Both the lenses satisfies this. Only there will be, according to the sign convention, the focal length may be positive or negative depending on whether it is convex lens or concave lens. But now we are not going in detail of such type of equation and then formulae, but we will discuss how there is a formation of image. I will let you know few images, and then as a homework you can prepare the images for the rest of the part. For that I will use this page on which I have drawn the position of lens first. This is a lens, therefore this will be the pole of our lens system. This distance is f, I have mentioned here it is f. This is 2f, I have mentioned it is 2f. And to the right side this is f and this is 2f. Now first of all I will assume that the object is at infinity, therefore the rays coming towards the lens are parallel to each other, and therefore I will draw, actually I will skip this because we know that suppose the set of parallel light is approaching towards the convex lens, after passing through the lens they travel towards the focus and there is a formation of point image. Therefore there is no need to draw this diagram with pen and pencil or scale etc. But we will consider remaining diagrams. Let the object is such that it is in between infinity, therefore infinity is greater than u is greater than 2f, therefore I will have to keep the object in between infinity and 2f. Now actually it should be far away from this, but here I can consider the point which is sufficiently or slightly outside this f. Now what will happen, we will discuss. Therefore here I will draw the object. Let the object is of size 2 cm, therefore this is my object. I will note it as O dash. What I will have to do, I will have to draw two lines, one parallel to the principal axis toward the lens, therefore this line or this ray is the parallel ray toward the lens parallel to the principal axis, and after passing through the lens it travels through the focus, correct? Therefore this will be the emergent ray, it travels like this. Okay, this is emergent ray. Another ray which is traveling towards the pole travels undeviated, because just now I have mentioned that, I remember that two rays are to be considered, one parallel and other traveling towards the pole. One parallel, other traveling towards the pole, correct? And therefore I will think about the ray which is traveling towards the pole, and you will observe that if this is a ray, then this ray after passing through the lens travels undeviated, and therefore these two rays meet each other at this particular point, and therefore there is an image formation, something like this. This will be the image. I will call this image as I dash, correct? I dash. Now you also might be remembering that there were different explanations. What about the image, whether the image is inverted image or it is as it is, whether it is magnified or whether it is diminished image, whether it is real or it is virtual image. Now after that, after some time we will realize what is the situation. Here we will say that both the rays are meeting each other, therefore this image is real, it is inverted, and you will observe that the size of image is less than the size of object. See here it is not 2 cm, it is 1.6 and so on, therefore it is diminished image. For the second diagram I will treat that the object is at 2f, therefore it is exactly at 2f, this point. Okay, therefore again I will keep the object as 2f, it will be the arrow O dash. Then again I will have to consider the ray which is parallel to the principal axis. This ray parallel to the principal axis. Actually here there is a lens, but I will not draw this lens. And after passing through the focus, this ray will travel through the focus. After passing through the lens, it will travel through the focus. Therefore this is the ray after passing through the lens. And the ray which is traveling towards the pole, this is the pole of a lens O, will travel undeviated, correct? Will travel undeviated, and therefore I can see that this will meet the first beam or the first ray at 2f, correct? This is at 2f, and therefore the image will be something like this. This will be the image. It is I dash, and interesting thing is that this image is exactly of the same size as that of object. Now in this case there may be a small difference, that means it may be 1.9 etc., but it is because of the error in diagram. That means I may not consider the exact point O, I may not draw the exact parallel line, exact f, and so on. But the formula also says that suppose there is the object distance which is minus 2f, then the image distance will be 2f. Okay. Now this is a diagram which represents that if the object is at 2f, the image is also as 2f. It is real image. Actual rays meet each other. Image can be brought on the screen. I can keep a screen here and get the image on that screen, and there is no magnification. It is inverted image. For the third diagram, I will consider the object distance u in between 2f and f. That is, this point is 2f, this is f, and my object is in between f and 2f. Therefore here I will draw arrow. Right? Now again it depends whether it is very much close to 2f or it is very much close to f or it is exactly in between f and 2f. You may, if you are interested, you may draw these diagrams as a homework. Again, what I will have to do, I will have to draw a parallel ray. Now here I am considering the parallel ray by taking the reference of the lines on the scale, and therefore there is a possibility of negligible error. After passing through the lens, such a ray travels through the focus. Therefore this ray, after passing through the lens, here it is a lens, passes through the focus. Therefore I will have to draw the light something like this. This is the ray. Whereas the ray which is traveling towards the pole travels undeviated, and hence I will have to consider here the ray which is traveling undeviated. Therefore I will draw the ray something like this, and here I will observe that if I extend this ray, they will meet each other far away from this, somewhere here, and therefore you will observe that I have not considered this object at f. What will be the reason? I will show you later on. But the image will be at this particular point. This will be the image, correct? This will be the image I dash, correct? And you will observe that this image is magnified. This is about 3.5 or 3.6 centimeter. Means if the object is in between 2f and f, the image produced because of the convex lens, now this is about the convex lens, is magnified and it is beyond 2f, correct? It is beyond 2f. Okay. Next I will consider the object at f, correct? Therefore suppose the object itself is at f. Now this is interesting. This is at f. Then again I will draw the ray which is parallel to the principal axis. This is the ray which is parallel to the principal axis. After passing through the lens, here it is a lens, here at this point, it passes through the focus and travels like this. And the ray which is traveling towards the pole, this is the pole of the lens, travels undeviated, correct? Travels undeviated, correct? This travels undeviated. Now you will observe that the lens is here it is a lens L, this is the pole O, this is object O dash. These two rays travels parallel to each other, therefore they never meet each other, or they meet each other at infinity, correct? They meet each other at infinity. Though I extrapolate the rays in reverse direction, in backward direction, again they will not meet each other, which indicates that the image produced is at infinity, correct? Either plus infinity or minus infinity, it depends, and for that we should know something else. But we can say that the image will be at plus infinity. And you will observe, suppose the object is at infinity, this object is at infinity, rays are parallel, the image will be at f, and if the object is at f, then the rays are parallel and the image will be at infinity, and it is expected. Now in the last case I can treat the object to be in between F and pole, that is 0. This is pole, the distance is 0. Therefore, I will have to keep the object in between F and O, that is pole of the lens. Again, this is the lens, here there is a lens like this, therefore this is the pole. I will have to draw first ray parallel to the principal axis, therefore this is the first ray, it is parallel to the principal axis. After passing through the lens, it travels through the focus, therefore this is the ray after passing through the lens. And the ray which is traveling towards the pole travels undeviated, correct? It travels undeviated, and therefore this ray travels undeviated. Now you will observe that here the rays are diverging from each other, correct? They are diverging. Here they are parallel, but here they are diverging from each other. And if I extrapolate them in reverse direction, backward direction, this direction, if I extend them in reverse direction, then they are supposed to be emerging from a common point. This is a common point, and they are supposed to be emerging from the common point. That means the observer will feel that the image is somewhere here. It is I dash, correct? This is O dash. The observer will feel that the image is somewhere here, right? And therefore this image is known as virtual image. If I keep a screen here, I cannot get the image on that screen because object is here, lens is here, and the image will be towards right side. But actual image will not be produced because the rays are diverging away from each other. Therefore, if I will have to observe this image, I will have to observe through the lens. That means I will have to keep the eye somewhere here. And if I observe from this direction, this object through this lens, then that will be observed at I dash. Now this is nothing but the magnification, correct? This is nothing but the magnification. In later discussion, you may go through the simple magnifier, that is the glass single lens, compound microscope. Then you may think about a telescope. You may go through the different eyepieces, and at that time you will realize that what is the role of magnifier or what is the role of eyepiece. Why the eyepiece is needed to observe the image. I cannot take that image on the screen directly, but I will have to observe through the eyepiece. Okay, and this is the eye, and this is magnification, simple magnification. Therefore, basically these are 6 images. Out of them, one image can be treated as a simple image, rays parallel to, that means object is at infinity, image will be at F. Object will be in between infinity and 2F. The image will be in between F and 2F. If the object is at F, 2F, the image will be at 2F. If the object is in between 2F and F, the image will be beyond 2F. If the object is at F, then the image will be at infinity. And if the object is in between F and pole, then the image will be at F and 2F, but it is virtual image. It will not be real. The rest of the images are real images. Now this is about the image formation due to the convex lens. In the next video, we will discuss how there is an image formation due to the concave lens. Thank you.